and 68, Kth smallest number in multiplication table. So for this problem, we need to know what is the multiplication table. Yeah, so nearly everyone has used the multiplication table. So the multiplication table of size m times n is an integer matrix mat. So where mat ij gonna equal to I times j. So we're gonna directly check the first example. We can see that. So first of all, it's gonna be 1, 2, 3, and then it's gonna be 2, 6, 2, 4, and 6, and then it's gonna be 3, 6, and 9 because it's gonna be, yeah, because for this, let me use another color. So this is gonna be the row, and this is gonna be the column. So for the row, it's gonna be 1, 2, 3, and for the column, it's gonna be 1, 2, 3. Yeah. So we can directly multiply, use the multiplication 1 times 1. 1, 1 times 2, 1 times 3, 3, 2 times 2, 4, 2 times 3, it's going to be 6. Yeah, as we can see, that the value for each of the row is going to be in increasing order, and for each of the column, we can also check that from the top to bottom it is in increasing order. This means we can solve the problem by using binary search. Yeah, but let's just continue. So given three integers m, n, and k, we're going to return the kth smallest element in the m times n multiplication table. So this is m and n 3 times 3, and we're going to return the fifth smallest integer. So we can say 1, 2, 2, 3, 3, and so we're going to return this is 3. Yeah. So the easiest way to solve this problem is by using binary search. So we're going to use a binary search to guess an answer. If our guess is right, definitely we're going to return this number if we can find it. Yeah. So the problem is that m and n going to be 3 times 10 to the power 4. This means definitely we cannot use binary search. This means we cannot produce a very long array like this, and then we're going to find the fifth element. Definitely we cannot do that. Yeah. Maybe you're going to think we're going to turn this 2D array into a 1D array, and then we're going to sort the 1D array and we get the final result. Yeah, but this 1D array is going to be 10 to the power of 8. Definitely it didn't work. So this means we're going to use a binary search to guess an answer. So for example, if we guess our answer maybe we're going to guess this answer maybe 9, it is too big, and then maybe it is smaller, maybe it is 3, and for this number 3, it is the fifth smallest element. So it is okay, so we're gonna return this number. Yeah. So let's just try to write the binary search template. After that, we're gonna use a check function to check how can we use this kind of method. Yeah, because while we are guessing this number, it can be 9, or it can be 6, or it can be 4. Yeah. So if this number is 9, we just need to count how many numbers it's going to be. Yeah, it's going to be less than and equal to 9. So definitely there are 9 numbers. Yeah, so this means it is possible, but our guess is too big. Maybe we're going to guess it smaller, maybe 6. 6 is also okay, 4 is also okay. Yeah, because for this 9, we're going to check how many numbers. There are going to be 9 numbers, which is going to be less than and equal to 9. But our k is 5. So this means it is okay, because 9 is more than or equal to 5. Definitely this is okay. Or maybe we're going to guess 6, or maybe we're going to guess 4. If we guess this number 4, how many numbers? So how many numbers are going to be less than or equal to 4? So 1, 2, 3, 4, 5, 6. There are going to be 6 numbers, but our k is 5. Maybe it can become smaller. So our last guess may be 3. So this is the method of binary search. So let's just first write it. So for me, I'm going to use R and C to represent M and N, because this is easier for me to finish the coding. Yeah, because sometimes I don't know M is the row, N is column. So for me, I'm going to use the row and column. So R is the row and C is the column. Yeah. So L, R, and the result. Let's just prepare the binary search first. Yeah, because for the final answer we're going to guess, so the smallest value may be 1, and the maximum value may be R times C. It's going to be the maximum. And the result may be 1. Yeah. Now let's just finish the binary search part. Yeah, because according to the multiplication table, this 9 is going to be 3 times 3. This is going to be the maximum number. Definitely, if we are going to check the case value, if it is valid, definitely we're gonna have the numbers between the minimum and the maximum, between 1 to r times c. So while L less than or equal to R, we're going to check M going to equal to L plus R divided by 2, and then we're going to use a check function. If this is okay, we're going to update the result. It's going to equal to M, and because it might be too big, so if it is too big, what are we going to do? We're going to update the R border, going to be M minus 1, what to make it smaller. Otherwise, we're going to update the L border, going to equal to M plus 1. So finally, we're going to return on this result. So now, what we need to do, we just need to finish the check function. So inside, I'm going to give a threshold. So according to the problem, we're going to set the row and column, as we can see, it is 1, 2, 0, 1, 2, 3, column 1, 2, 3. So we don't need to use the index 0 to n minus 1 or r minus 1 or c minus 1. We can directly use the index from 1 to r or 1 to c. Because for calculation, it is just okay. So for example, if our guess is 3, so if 3 is the threshold, so for example, check M, it is 3. We just need to count how many numbers it's going to be. It's going to be. So if our guess is 3, we just need to check how many numbers it's going to be less than or equal to 3. So 1, 2, 3, 4, 5. There are 5 numbers less than or equal to 3, and these 5 numbers are going to be more than and equal to k. Definitely, this means it is possible. But how can we check that? We can check column by column or row by row. Definitely, it is possible because it is monotonic increasing for each of the row or each of the column. So let's just check column by column. So if this is possible, for example, this number is 3 possible. Definitely 1 and 2 is possible because 3 is the maximum number in the first column. And then we're going to shift to the second column. And 6 is more than 3. And then we're going to check 4. 4 is more than 3. Then we're going to check 2. So 2 is possible. And then we're going to shift to the next column. So 9 is not possible, 6 is not possible, but 3 is possible. So we're going to count 3. So in total, we're going to count how many numbers. So it's going to be 5. So in this way, the time complexity for the check is going to be ON or OM. It's going to be 10 to the power of 4. Because for maximum, as we can see here, we just check one number. And for here, we also check a few numbers. So we check this column. 3 is okay, and then we're gonna find this 2, and this is 3. But let me just finish the coding first. I think it's gonna be more clear to explain this area. So we're gonna set a row and a column and a count. So the row gonna be R, and the column we're gonna start from 1 instead of 0 because this is easier for the calculation, and count gonna be on 0. So while the row more than or equal to 1 and the column is less than and equal to c, because currently the index is not 0 to c minus 1, it is 1 to c, it is 1 to r. So that is what we are doing from here. So we're gonna check the last number. We're gonna check this number 3. So it's gonna be R times C. So C gonna be the first column. So R gonna be the last row. So while R times C is less than or equal to threshold. So currently, let's just guess our threshold may be 3. So we're gonna update the count. So the count gonna plus equal to R. It depends how many rows, and we're gonna update the column to the next one. So the column gonna be here. It's gonna be the next one. Otherwise, if it didn't meet the condition, what are we gonna do? We just needed to update the row to R minus 1. Yeah, so in this example, let me just explain. So here the time complexity is going to be O(n) instead of m times n. Yeah, let me just explain about here. Yeah, so here, so for example here we checked 3 is okay. So this is just we just check one time. We just check this number 3, and now we're gonna check this 6. Yeah, so 6 is not okay. Definitely 9 is not okay. Now we're gonna jump to this this row, and 4 is not okay. We're gonna jump to this row. Now we only need to check this number 2 and this number 3. So this means the time complexity is gonna be O(n) or O(m). Yeah, or O(m) plus n, definitely. Yeah, definitely O(m) plus n. We saved the time. Yeah, so the time complexity is gonna be O(m) n times log m times n. Yeah, so this is why, yeah, we solved it. We can solve it by using binary search. Yeah. Now let's just finish the final part. So the final part, we just need to return how many code, how many numbers, and all those numbers should be more than and equal to k. So according to our definition, if the code is more than and equal to this k is 5. So for example, if we are guessing number 9, so our code is 9. 9 is more than or equal to 5, definitely. Yeah, definitely this is possible, but it is too big. We still want to find a smaller number, maybe 6 or maybe 4 or maybe 3. Yeah, so this is why we're gonna write it like this. Let me just run it and submit it to check if it works. Yeah, as you can see, it works and it's pretty fast. Thanks for watching. See you next time.